Welcome to the Technology with Purpose channel. Today, we are going to learn how to calculate the correct RMS value of a distorted sine wave using LabVIEW. When the waveform is distorted in the initial portion, it's likely that the RMS calculation will be inaccurate due to the initial peak distortions. To calculate the correct RMS value, it is important to first remove these distortions and then proceed with the calculation. So, today we'll learn how to do that using LabVIEW. First, we need a sine wave with distortion. Let's open LabVIEW, generate the sine wave, and collect the data samples. I'll use a LabVIEW 6 virtual instrument to generate the sine wave and pass the parameters to the 6. Now you can see I have a sine wave without distortion. To introduce some spikes, I'm going to manipulate a few of the samples, specifically, the initial samples, to create a distorted waveform. As you can see, I've altered some values in the array. Let's check how the waveform looks now. You can clearly see that in the initial portion of the waveform, there's visible noise. Now, let's calculate the RMS of this distorted waveform using LabVIEW. I'll use the basic LabVIEW function to calculate the RMS value. You can see the RMS value on the screen. We can also see the DC components, but since this waveform has distortion in the initial phase, the RMS value may be incorrect. Let's first crop the waveform so that it starts in the positive phase with no distortion. To do that, we'll crop the waveform by removing the negative samples from the first cycle. I'll compare each sample with a threshold value, which can be any positive value. From the point where the waveform meets this condition, we'll subtract all the data points before it. To implement this, I'm going to use a for loop along with conditions to check this comparison. Now I've identified the starting point of the dataset. Next, I'll subtract a few more samples to remove the first negative peak of the waveform. The number of samples to remove may vary depending on the sampling rate of the data. I can increase it to 100 samples and check again. Now the waveform starts with the positive cycle. I'll stick with 100 samples here. Now, let's calculate the RMS of this filtered waveform using the same basic RMS 6, and let's also calculate the DC components. You'll notice there's a significant difference between the first RMS value and the new one. This is how you can accurately calculate the real RMS of any waveform using LabVIEW. Thank you so much for watching. If you found this video helpful, please don't forget to like, subscribe, and share. Thank you.